Hello everyone, welcome to new class. Today's class is about graph theory, that is graph theory in circuit theory. So, graph of a network is a geometric figure in which all the passive elements are represented by line segments, that is passive elements by line segments. Then all the voltage source ideal voltage sources are represented by short circuit. Then all the ideal current sources are represented by open circuit. So a graph of a network is a geometric figure in which all the passive elements are represented by line segments. All ideal voltage sources are represented by short circuit and all ideal current sources are represented by open circuits retaining all the nodes. So what do you mean by node? Node means it is the junction of two or more elements. So the junction of two or more elements is called node. Then what is branch? The elements which may be active or passive connected between nodes is called branch. So the elements, that is passive or active elements connected between nodes is called branch. Then what is mesh? The closed path for the current to flow is called mesh. So consider a network shown in the figure, that is a network means it is an interconnection of elements in various branches at different nodes. So 1, 2, 3, 4 are the 4 nodes. Then we have to draw the corresponding graph. So first of all mark the nodes 1, then 2, 3 and 4. Now 1 to 2. So it is a line segment, then 2 to 3 also a line segment, 3 to 4, then 1 to 4, then 2 to 4 is a line segment, and from 1 to 3 there is a voltage source, so we have to short circuit. So it will be like this. So this is the graph corresponding to the network shown. So this is the branch A, then B, C, D, then let this be E and F. So this is the graph corresponding to this network. So as already told, the branch is represented by a line segment connecting pair of nodes in the graph of a network, and node is a terminal point of a branch which is represented by a point. Then nodes are the end points of branches. So nodes are the end points of the branches. Then this graph can be drawn like this. That is, this graph can be drawn in this way also. So here there are 1, 2, 3, 4, 5, 6. So 6 branches are there and 4 nodes are there, and these two graphs are undirected. And if every branch of a graph has a direction, so if every branch of a graph has a direction, then it is called a directed graph. So this is called undirected graph and this is called directed graph, or we can say it is oriented graph. And a node and a branch are incident if the node is a terminal of the branch. And nodes can be incident to one or more elements, and the number of branches incident at a node of a graph indicates the degree of the node. Degree of node means the number of branches incident at a node. That is, for example, this node 2 has 3 branches incident at this node. So, the degree of the degree of node 2 is 3. Similarly, degree of node 4 is also 3. And a graph is connected if and only if there is a path between every pair of nodes. So this is about the undirected and directed graphs. Next is planar and non-planar graphs. So a graph is said to be planar if it can be drawn on a plane surface without any crossovers. So look at this graph. So there is a crossover here, but this graph we can draw in another way. That is, this crossover we can draw like this. So this is a planar graph. That is a graph which can be drawn on a plane surface without any crossovers is called planar graph. So this is planar graph, and non-planar graph is the graph which cannot be drawn on a plane surface without a crossover. So in non-planar graphs there will be crossover. So this one we cannot draw in another ways. So because here if we take this line to this side, then there will be a crossover in this way. So this is non-planar graph because we cannot draw this graph on a plane surface without a crossover. So this is planar graph and this is non-planar graph. Next is tree and chord tree. A tree is a connected subgraph of a network which consists of all the nodes of the original graph but no closed path. So, a tree contains no closed paths and it is the subgraph of the original graph, and the number of nodes is equal to the number of nodes in the graph. That is, the number of nodes in a graph is same as that of the number of nodes in a tree. So nodes are same. That is, if a graph has 3 nodes, then the tree also will have 3 nodes. And the number of branches. So number of branches in a tree is less than the number of branches in a graph. So number of branches is less than the number of branches in graph. So a tree is the subgraph of the graph, original graph, but it has no closed paths and the number of nodes are same as that of the original graph in a tree. Then the number of branches in a tree is less than the number of branches in a graph. So consider this graph. Then how will you draw the tree? So a tree has no closed path. So we can first of all draw the three nodes. So 1, 2, 3. Then how will you draw the open path? So 1 to 2 we can draw. Then 2 to 3 also we can draw. If we connect this one, then it will be a closed path. And if we connect this 2 to 3, that is the D, branch D here also, then it will be also a closed path. So this is one tree of this graph. So if a graph has n nodes, then there will be n minus 1 branches in a tree. If a tree contains n nodes, then there will be n minus 1 branches in a tree. That is, here there are 3 nodes, then the number of branches are 3 minus 1, that is 2. 1, 2. And these are different trees for this original graph. That is, here this B and C branch we can remove, and that will be an open path. So it is also a tree, and these are also trees for this original graph. And here, in forming a tree for a graph, certain branches are removed or opened. The branches thus opened are called links or link branches. So, links are the removed branches to get a tree. So, for this one, the removed branches are A and D. Hence, A and D are called links for this tree. Similarly, for this tree, the removed branches are B and C. So, B and C are the links for this tree. Then, what is core tree? So, core tree of a graph means the set of all links of a given tree. The set of all links of a given tree is called core tree of the graph. So, for this tree, core tree means B and A and D. So, here A and D consist of the core tree of the given tree. That is, core tree means the set of all links of a given tree is called core tree of the graph. So, here core tree means A, D. Here A and D are called the links. That is, the removed branches are called links. Then next is the difference between twigs and links. So, link means the removed branches of a tree is called link, and the branches of a tree are called twigs. So, twigs means the branches of a tree. So, in that case, the branches are B and C, and links are A and D. So, the branches of a tree are called its twigs, and removed branches are called links. So, twigs are the branches of tree, and links are the branches of core tree. So, that is the difference between twigs and links. Twigs means the branches of tree, of a graph, and links means the branches of chord tree of a graph. And we have already told that if there is n nodes, then there will be n minus 1 branches in a tree. So the number of twigs are n minus 1. So the number of twigs for a selected tree is n minus 1, and the number of links is b minus n plus 1. So number of links for a tree is b minus n plus 1, where n is the number of nodes and b is the number of branches. In this case, n is 3. So 3 minus 1, 2. So the number of branches in or number of ticks is equal to 2. And here number of links is b minus n plus 1. So b is number of branches. So number of branches is 1, 2, 3, 4. 4 minus, then n is 3, then plus 1, that is equal to 2. So number of links is also 2. So if we want to make tree, then we can use this equation, that is from a graph to a tree, use this equation to remove the number of branches. That is, we have to remove some branches from a graph to get a tree. So that number of branches to remove or the number of links to remove is equal to b minus n plus 1. And the number of twigs is known as tree value of graph. So the number of ticks is known as the tree value of the graph, also called the rank of the tree. And if a link is added to the tree, then the resulting graph contains one closed path called a loop. And also the number of loop is also equal to b minus n plus 1. So this equation is used to get the number of links and also the number of loops in a network. So that is about the basics of graph theory. Hope you all understand about this graph theory. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.